Hello everyone, my name is Mulutra Enoch and we are going to revise together CH110 under gases, and the question reads: the air that we breathe is about 21% oxygen by volume. Exhaled air contains 14% oxygen. The absorption of oxygen within the lungs takes place in tiny spherical compartment called alveoli, which have the radius of 0.1 meter. Estimate the number of oxygen molecules absorbed in one breath in each of the alveoli. Assume the body temperature is 37 degrees Celsius. So what you're going to do there is that you're going to find the number or the amount of oxygen that was absorbed in the alveoli. So to do that, or that can be achieved by subtracting the number of oxygen or the amount of oxygen that was inhaled, subtract it with the amount of oxygen that was exhaled. So to find the oxygen that was absorbed, oxygen absorbed is equals to 21% minus 14%. So when you subtract, you're going to find 7%. So 7% was the amount of oxygen that was absorbed by the alveoli of the lungs. So from there, now what you're going to do is that you're going to find the volume of oxygen that was occupied by the what? By the absorbed air. So now they are saying the absorption of oxygen within the lungs take place in a tiny spherical compartment called the alveoli. So meaning when they say spherical, they are spherical, it means that you're going to use the formula for what? For calculating the volume of the sphere, which is volume is equals to 4 over 3 pi r cube. So this is the volume of the what? The sphere. Because of the shape of the what? Of the alveoli, which are spherical, so that implies that you have to use the volume of the sphere to calculate the volume of oxygen that was absorbed. So volume is equals to 4 over 3 pi, that is 3.142. Now there they have given us the radius to be 0.1 millimeter, but the thing is that whenever you are replacing this formula, make sure your radius is in meters. So what you are going to do is that you are going to convert 0.1 millimeter to what? To meters. So divide by 1 times, so 10 millimeter is equals to what? 1 centimeter. So that one will cancel, also that one will cancel, and then another thing, that is 100 centimeter is equivalent to what? 1 meter. So centimeter goes, and you're going to obtain 0.0001 meter. But you can simplify this one further by writing it in standard notation form. So 1, 2, 3, 4, that is 1.0 times 10 to the negative 4 meter. So this is the radius that is supposed to be there. So that is 1.0 times 10 to negative 4 cube. So from there we proceed. So we are going to punch everything on your calculator. So when you divide 4 over 3, you are getting 1.33 recurring times 3.142 times. So this 3 is scattering for everything inside. So 3 to power 1, that is 1. So 1 times, so 3 times negative 4, that is 10 to power negative what? 12. So to simplify that, you're going to multiply. So we are going to obtain 4.19 times 10 power negative 12 cubic meter. Now bear in mind to say that this value that you have calculated, that was the volume that was occupied by the gases, by the gas called oxygen that was entering in the lungs. But they are saying estimate the number of oxygen molecule absorbed in one breath in each of the alveoli, and you have calculated to be the volume of oxygen that was absorbed to be 7%. So whenever they say each of the alveoli, meaning you are going to multiply 7% of the oxygen that was absorbed with the volume that you have calculated there to find the total volume. So you are going to multiply, that is total volume that was occupying the alveoli, 4.19 times 10 power negative 12 times 7%. So that is VT. Then you multiply. So when you multiply everything, you are going to get 2.933 times 10 the power negative 13 cubic meters. So this 7% you can write it as 0.07 by dividing by 100. Now from there, what you are going to do is this. They have given us the temperature to be in what? Degrees Celsius, but it has to be converted in Kelvin. So temperature in Kelvin is equals to temperature in Celsius plus 273.15. So temperature in Kelvin, so you have to add 7 plus 273.15. So when you add, you are going to get temperature in Kelvin to be 310.15 Kelvin. So now from there, what you are going to do is this. You are going to find the number of moles. Now the number of moles is going to be calculated by this formula. So pressure is equals to number of moles. Pressure is times volume is equals to what? Number of moles RT. So they were saying the body was 37 degrees Celsius. So one thing that you should bear in mind is that when the body is at room temperature, it means that the temperature is going to be 37 degrees Celsius. That is RTP. Now the condition is that what is the pressure at RTP? So the pressure at RTP, that is 1 times the total volume that we have calculated, 2.933 times 10 to the power negative 13 is equals to N, and then the constant value, universal constant, that is 0.08206 times temperature 310.15. Divide both sides to find the number of moles. So the number of moles is equals to, so the number of moles, that is 1.15 times 10 to power negative 14 moles. Now bear in mind to say that there they are saying estimate the number of oxygen molecules. So we have learned about the Avogadro's constant and how to find the number of molecules, atom particles that are given. So from there, what you're going to do, you're going to write the Avogadro's formula, that is number of molecule is equals to number of moles times the Avogadro's what? Constant. So number of molecules is equals to the number of moles that you have calculated, that is 1.15 times 10 to power negative 14 times the Avogadro's constant, which is 6.02 times 10 to power 23. So the final answer is going to be 6.923 times 10 to power 9 molecules. So from there, this is the final answer. That was the number of oxygen molecule that was required or absorbed together. So please don't forget to like and share, also subscribe, so that whenever I post the new video, you're able to see and watch. See you in the next video.